Hello.
Hello, welcome. All right. So typically we wait a few minutes for folks to turn up, usually about 5. While we're waiting, it's very handy to go add yourself to the attendees list in the meeting minutes. Also, if folks have things they would like to talk about, we do keep a pretty open agenda, so feel free to add your agenda item at the bottom. And we'll, as I said, we'll allow a few more minutes for folks to turn up. So for folks who are just joining, feel free to add yourselves to the attendees list there at the link in the chat. Also feel free, if you have agenda items you'd like to discuss, to add them there. We usually get going about 5 after or so to give everyone a chance to show up. So again, welcome to folks. We'll probably get started in about 2.5 minutes. If you could add yourselves to the attendees list at the link in the chat. Also, if you have agenda items you'd like to discuss, please feel free to add them to the agenda. We keep a pretty free-form agenda here, so we often take additions from folks as we go. Okay, so we'll probably get going about now. I've put a link in the chat for folks to add themselves to the attendees list or add them agenda items. And when we get down to the agenda, we can sort of figure out the order of operations. Let me go ahead and share the agenda so we can talk through it. We've got a pretty full agenda today, so it should be great fun. All right, welcome. This is the Network Service Mesh call for Tuesday, April 27th. as I mentioned, please feel free to add yourself to the attendees list. The agenda, we have a bunch of recurring agenda items. So in addition to this call at 8 a.m. Pacific time every Tuesday, there is a call just before it, which is on the calendar at 7:30 a.m. Pacific time every Tuesday, which is the issues and PR meeting. And that one is just sort of the blocking and tackling of walking through the issues and the PRs. In terms of the agenda, we also have other communities that we participate in. So we tend to participate in the CNCF Telecom Users Group, which is usually the first Monday of the month, but it's going to be bumped back a bit because of the conflict with KubeCon. And we also participate in the CNCF SIG networking meeting, which is the first and third Thursday of every month at 11 a.m. In terms of upcoming events, KubeCon EU Virtual is coming up May 4th through 7th. And we do have a keynote that I know will be mentioning us there. So definitely do go take a look at the mesh has immense psychological value. Should be a good time. And then coming up October 12th to the 15th, KubeCon North America is happening. It'll be a hybrid event, so there will be some in-person attendance in Los Angeles, but I expect there also will be remote attendance as well, because I think the world is going to be in a very broad set of states in terms of the pandemic recovery. Things are going pretty swiftly on vaccination in the US, but I know it's not quite the same everywhere else. Any other events that we should be aware of that we want to list here and promote? All right, excellent. So moving on to social media, we have an excellent social media sub-community in Network Service Mesh. So this week we picked up 6 additional followers. We're following 24 more folks, and we made 12 tweets. We tweeted about CNCF workshops, the new Kubernetes release, and the update to the release cadence for Kubernetes, the Linux Foundation mentorship program announcements, some various other things happening in the industry. And all of that got mirrored to LinkedIn. We tend to be a much more heavily Twitter community than LinkedIn community. Cool. Anything else before we jump into our agenda? So I would suggest that maybe we rearrange the order of these somewhat. I appreciate folks sort of adding themselves to the end of the agenda, but I think probably it would be good to talk first about the P2MP forwarder proposal and then the sort of demos of things. Does that make sense to folks? Don't all speak at once. Okay. So Jan, I believe you were talking about the point to multi-point forwarder proposal. Did we lose Jan? Or is Jan having trouble with the mute button? I think that was you, Jan.
Yeah, sorry, I'm back now. I had to open the door.
It's okay, this happens. So I'm going to stop sharing. I believe you have something you wanted to share and walk through.
Oh, you want me to start? No. I thought it was at the end of the agenda. Okay.
You missed the part where I suggested reordering the agenda.
Okay. Yeah, sorry. Good, then let me try to bring this up quickly. Where am I?
Yeah. Murphy's Law being what it is, the one time you step away is the time the agenda gets reshuffled to put you first.
Yes. Okay, let's see. No, not the right one. This should be the right one. Okay.
So by way of context for folks, while you're digging up the slides, there had been a bunch of discussion a few months ago about some use cases that folks had that required being able to, for the purposes of efficiency more than anything, incorporate some point-to-multipoint functionality within the forwarder. Because you could always logically break that out from the forwarder, but then you have an additional hop, which precludes certain use cases that people wanted to be able to carry out. And so after a lot of discussion back and forth, I think you've got a proposal for how we might neatly achieve that end, correct?
Yes.
Excellent.
So
You ready to share?
Let me try to bring it up. I have
I see
no
you,
idea if I'm. And what is it that you see? Do you see the slide deck?
I see the slide deck, yes.
Okay, cool. And do you still see the slide deck in full screen mode now?
Yep.
Okay. Good. Yes. So thank you, Ed. We from Ericsson brought this topic up in October, and I'll briefly do a maybe 5-minute recap to say where we are coming from. The use case that we are addressing is a use case where our network service clients are actually not clients, but they are servers. So they are the target of traffic coming from external networks. And the network service that we are looking at is a load balancer service that load balances the ingress traffic over the range of target pods. So it's a load balancer with specific properties for secondary network traffic. Nutless and stateless and a number of other things. And with the classical network service mesh paradigm, each client is connected to a single NSE instance. And that is a problem if the ingress traffic is randomly distributed over all the NSE load balancer instances, because only one has actually an uplink to the target pod and the others don't. So what we need is instead a full mesh where each load balancer instance has access and connectivity to all the targets that it needs to load balance to, and the clients can send their traffic out basically through any of the instances. And the main reason we need to do this is we need scalability here in the load balancer. We need to have multiple load balancer instances for scalability reasons. And that is simply not doable with the existing NSM unless you do something and inject a proxy service in between that hides the distribution of the load balancer service from the clients. But injecting a proxy network service is possible, but it's inherently inefficient and has some other problems. So we don't want that. And when we brought this problem up in October, as I said, you acknowledged that this is a valid use case, but it's a special use case also. And there are too many potential flavors of such point-to-multipoint forwarding to build a single such model into the core NSM. And instead, the ask was to look for a more modular solution so that the basic NSM point-to-point cross-connect model could be augmented by any number of different point-to-multipoint flavors as extensions in a modular fashion. And the guidance that we got at the time was look at the forwarders, because next-gen NSM will support kind of special purpose forwarders, and it's much easier to embed special purpose forwarding behavior into forwarders than build it into the NSM core itself. And then we started the discussion that went along for many weeks, Ed and I, and we met fairly regularly, I would say, in this time frame, and bounced a lot of ideas. So the initial discussion you can still see in this discussion document was pretty wild, and it's fairly outdated, but the ideas are, many of the ideas are still covered in there. But in the end, the
discussion document is full of many rejected ideas. Yes.
Exactly. So don't pay too much attention to the discussion document, but the proposal document, even though it's not entirely complete, I would say it's at least it covers basically what we finally agreed upon after these many discussion rounds. And today I'm going to show you in a couple of slides what we have basically homed in on. So this is the top level that I have here to summarize basically the main ideas. We have the NSM manager. We have a couple of forwarders, different forwarders that it can choose from. And we have standard forwarders like forwarder A, and we have also a forwarder B that has a new capability to do point-to-multipoint forwarding that will prove to be essential. And then we have a service with multiple NSEs, and that has a service manifest. And in the manifest, we will have additional information as metadata labels. Basically, that the service can specify in order to indicate that it does more, it needs more than standard point-to-point cross-connect. So here the example is it specifies a label that says point-to-multipoint true. And when a client comes and says, I want to connect to that service, then the NSM manager will do a lookup in the registry and will figure out that the service has this annotation. And this annotation will then be considered in the forwarder selection. And only forwarders that have a corresponding label, advertise the corresponding label themselves, are eligible for forwarding. Forwarders that have not are not eligible. So NSM manager would select forwarder B and forward the service request to forwarder B. Now, forwarder B has, of course, advertised point-to-multipoint capabilities, so it knows what to do with point-to-multipoint. The crucial change now, compared to the design base in NSM, is that forwarder B will go and actually do another lookup of the network service in the registry and detect that there is a label point-to-multipoint 2 that requires, and that will trigger forwarder B to not do a simple point-to-point cross-connect, but to do a point-to-multipoint cross-connect. And it can do that because it had advertised that it has this capability.
Yep.
In this case, then forwarder.
And there are any number of ways it might do point-to-multipoint. You know,
yes.
There are not literally millions of them, but there are a large number of them.
Exactly. And this is just an example. There will not be most likely a single label point-to-multipoint, but there may be many different labels, or in addition to the point-to-multipoint label, there will be additional labels that say what flavor and so on. So that is all is possible. So there can be more than one label, and point-to-multipoint is just an example. Anyway, in this case, forwarder B will know its point-to-multipoint that is requested, so it will look up all the network service endpoints for that network service, and then it will go and establish a connection to all of them. And when it is done so, then it will set up internally the cross-connect between the single leg towards the client and the multiple legs towards the endpoints. That's forwarder specific. And then it will reply with a single connection back through NSM manager to the client. So that's basically the flow. We have an annotation of the service, we have forwarder capabilities, and we are moving the network service endpoint selection from network service manager to the forwarder. Those are the three main ingredients to the proposal. Is that right, Ed?
That's an excellent high-level summary of both the discussion and the proposal. Obviously, there are details below that, but if you start with details, people get lost.
Exactly. So I don't think I have to go much further, but I can give you, let's say, example manifest where we have played this through. So in the simple case where you normally wouldn't even have a service manifest because it happens implicitly when the network service endpoints register themselves. So a single hop service, basically just a client connecting directly to service. In order to do a point-to-multipoint here, you would have to really specify the forwarder, no, sorry, the service when it registers would specify these metadata labels. In a composite service where you have multiple stages or a graph, each graph represents to a match statement, and what we have said is that every such edge in the graph match statement can be annotated. So in this case, we have a two stages. The first stage from the client to the FUU network service endpoint is point-to-point, but the next stage from the FUU to the bar network service endpoints, that is point-to-multipoint. And here we have said the multiplicity should be 3. So it should not connect to all network service endpoints with that label, but to exactly 3 of them. And that is a capability of a forwarder that is needed in addition to the basic point-to-point multiple capability. So these are the service manifests. For the forwarder registration, the forwarder would basically advertise its capabilities as labels. Every forwarder, or the standard forwarders, would advertise a kind of well-defined capability called P2P. And the forwarders that do more than that would, in addition to P2P, advertise point-to-multipoint, or if it's a special purpose forwarder, would only advertise point-to-multipoint with special capabilities. For example, here saying, I can satisfy multiplicity requests from a service, any number of integers allowed here. And then NSM Manager would do forwarder selection based on the input received in the service manifest and the forwarder capabilities, and you can basically do this matching, mix and match yourself. A service that has no special requirements implicitly means point-to-point. So any forwarder that advertises point-to-point is eligible. So NSM would pick any one of those, or depending on other criteria like requested local mechanism, those are not touched by this proposal. And in this example here, on the first hop is a standard point-to-point, so these two are applicable. The second hop in the service is point-to-multipoint with a multiplicity requirement, and then only this forwarder is eligible because it advertises both point-to-multipoint and a multiplicity that covers the requirement. And then the forwarder behavior I have already talked about roughly what it does, so I don't need to go through this. I just want to mention one thing. Typically, not typically, but if a client connects to a service that that requires a point-to-multipoint forwarder, the point-to-multipoint cross-connect is established by the forwarder that is local to the client. And then, of course, it can have remote network service endpoints on other nodes. And on the other nodes, there will also be a forwarder involved in completing the cross-connect to the network service endpoint there. And the difference is that in that case, the network service endpoint is already selected. And if the network service endpoint is already selected, then the NSM Manager would always invoke a forwarder with point-to-point capability, and not, again, based on the service, a forwarder with the requested point-to-multipoint capability. So these remote forwarders are basically the standard point-to-point cross-connect forwarders and nothing else. Okay, and the details of the flow are captured in these activity diagrams for the local case and for the remote case. I don't want to go through them in detail. They are clickable here, and you can look at the source also if you want. And that is basically what I wanted to show today.
Cool. And if you could add the link to the agenda so that folks can find that.
I will.
I
will do that.
That would be fantastic.
Right away. Yeah.
Do folks have comments, questions, thoughts?
I have one question. Jan, you said that when you define a network service and the network service manager actually picks the right forwarder, and then the forwarder tries to actually with a call to get the network service and check the point-to-multipoint through there. Why forwarder should do that? Why we cannot do this through the NSM manager directly, like feed that point-to-multipoint through to the forwarder directly, so the forwarder knows that it needs to actually connect to all the endpoints?
So it's a complexity. So there's a trade-off here between complexity and latency, right? Which I suspect is the sort of root of your question, correct?
Mm-hmm.
So it happens to be the case the Network Service Manager already today caches its lookups of information about network services and network service endpoints. The result of which is the forwarder asking the Network Service Manager, please tell me about this network service that you have already looked up, is literally a gRPC call to an in-memory data structure that then returns. So the latency is extremely small. And on the other side of that, the complexity of passing along that information to the forwarder would require increasing the complexity surface of the API by a fairly large margin. And so weighing those two, the having the forwarder make a lookup the Network Service Manager has already made, effectively, it's the latency is close to, not perfect, but close to what it would be with having to pass that information on proactively from the Network Service Manager. Does that make sense?
The forwarder actually gets this network service from the Kubernetes API or from the Network Service Manager with an RPC call?
So here's the thing: the Kubernetes API so the network service mesh itself. While we have a registry that will store things in the Kubernetes API server, Network Service Mesh itself is not actually bound to the Kubernetes API server at all. So when the Network Service Manager does a lookup, it's not looking it up in the Kubernetes API server directly. It's sending a gRPC call to a registry. And likewise, when the forwarder does it, it sends a gRPC call via the Network Service Manager to the registry.
Okay, that makes sense. Okay, thanks a lot.
No, given what you thought was going on, oh my God, no, that would be terrible. Because the latency to the API server is not fantastic. You know, that's an expensive lookup to do twice.
Okay, yeah, makes sense. Makes sense. Yeah, thanks for the clarification.
Yeah. I always love understanding where the roots of people's questions and concerns are. It's always very instructive.
Yeah, and it's a good question, Dimitris, because I had the same concern myself when I drew this again after a long time. And I didn't have this background information either, I must say, about the characteristics of this lookup.
Yeah, so one of the things that's amusing is you want things that look highly integrated, but that aren't, right? You want good, strong modularity, and we look really integrated with the Kubernetes API server because the default registry implementation backs onto it. And that has lots of really nice benefits, but happens to be true. It's not intrinsically always going to be true. And that sort of has to be the case because you could easily imagine people wanting to run all kinds of registries that aren't attached to Kubernetes. Cool. Other sort of questions and comments from folks?
Yeah, when you have this group of NSEs, network service endpoints, and you get the connection request, would you load balance the request or something? So will you have would you need to have like a synchronized IPAM between all of them, or how would you solve that?
So this is where you remember where I think Jan made this point originally, and I sort of reiterated this point, that there are a bunch of different ways to do both point to multi-point and also to do the kinds of network service endpoints that would be involved there. And so part of the reason for having a flexible modular architecture is my expectation would be that your NSEs in this example would be coordinating their IPAM, because otherwise you're going to have issues, right? But how you coordinate that IPAM is up to them.
Either it's like you say, it's up to them, or you say that the forwarder will select one NSE as the primary one, and it will actually replay the reply to the other one, and then you could actually update all your states in the background.
Also a perfectly valid approach. And quite honestly, my guess is that that's two approaches of many, and that it will take a little bit of operational experience to figure out which of those are the optimal ideas for given use cases.
So it's not covered in this sketch how to do this stuff.
No, this is just the framework on how to make point-to-multipoint forwarders possible. There will be different point-to-multipoint forwards with different operational principles, and the capabilities and the way of working of a forwarder has to be somehow well known and well documented, so that a network service that relies on the services of a point-to-multipoint forwarder knows which point-to-multipoint forwarder to choose, and the selection will happen through these kind of labels.
But I think if you leave all the synchronization stuff to the NSE itself, like outside the NSM framework, then the solution will not be like it will not be fully covered. I mean, it will not work unless you do a lot of stuff outside NSM. If the forwarder would actually have a method of like telling how to do this connection and reply and stuff like this, that would be easier.
No. So what you're making is a really good argument for the particular solution you put forth, right? And you're making valid points on all of that. The underlying point, I think, here is that there are lots of ways the forwarder could handle that. And network service mesh itself is agnostic as to the choices you make in your forwarder that has whatever kind of point-to-multipoint capabilities that it has, right?
But that also means that NSM is also agnostic to point-to-multipoint. If you cannot do it without like invent a lot of things behind the curtains.
Yes, I mean, that's the point. I think you're right, Anders. Essentially, it means the core NSM doesn't care, right? It doesn't care, and it is really up to the forwarder and the services that are making use of the services that the forwarder provides to provide an end-to-end solution that works.
So a specific forwarder label will actually dictate a lot of rules around that one.
Absolutely, yes. So when I come with a point-to-multipoint forwarder, I really carefully need to document what it means and what label to choose, and if there are multiple labels to choose in order to tune this way or that way. And then the network service have to pick the right label and adjust their implementation to the semantics of the forwarder.
The one very strong recommendation that I would make to implementers of forwarders would be make this label like PTMP true, make that configurable by an environment variable, because that way if two different folks working independently come up with the same pair of labels, I can simply reconfigure forwarder B to use a slightly different label and make sure I use that label correctly in my network services. Does that make sense? That's a loose coupling principle. Yeah.
Maybe, but I mean, somehow the semantics of the forwarder need to be coupled to some well-defined label. And if you make the label completely configurable, then anything will happen. So we have to see.
That's certainly something that could be sorted out. And I suspect, as we will see, well understood labels emerging over time for such things, as people sort of shake out the various kinds of semantics.
And we can prefix labels also with a namespace type of.
There's a huge amount of flexibility to sort that problem out. I agree.
Yeah. Okay.
Were there other questions or comments?
I have one question related to this remote case. So in case of remote NSE, the forwarder B, that still needs to connect to the remote forwarder, right? So we can't directly connect to remote NSE to establish the tunnel.
No, you're absolutely correct. Effectively, so here's the thing to remember: what the forwarder network service mesh has locality of information. And what that means is that the forwarder, when it does a lookup and tries to connect to what it thinks is a network service endpoint, the URLs that it's going to get from the registry are actually the URLs of the network service manager on that remote node. And that network service manager, just like today, will receive that request. It's just, I, as the forwarder on the originating node, can't tell the difference between can't tell that there's a network service manager necessarily between me and the forwarder on the next node, on the remote node, and then the network service endpoint of the remote node. All I know is I asked for NSEs, the NSE gave me a URL to make a request for it. Does that make sense?
Yeah, but still, like, we need to create the vWire, right, between client and the endpoint.
Oh, absolutely. So
that is being done by the forwarder, that local forwarder.
Exactly. Yes. Go ahead.
No, I mean, go ahead, Ed.
I
can give it a try because I'm an outsider. So the local forwarder, the point-to-multipoint forwarder, selects the endpoint that it wants to connect to. Then it sends the request to the remote node, and it ends up at the NSA manager on the remote node. That one selects the forwarder, right? And since the NSE has, the network service endpoint has now been selected, it goes to a point-to-point forwarder.
And when the forwarder sends the service request, that will go via the local NSM manager, or it will just directly go to the
it may help if you scroll up to the headers for the columns. The swim lanes are unlabeled as you're sharing it currently, and that may be causing confusion.
Yeah.
Okay.
So this is the dividing line, right? So it's the forwarder on the first node sending the request to the NSM manager on the second node.
Okay.
Right?
Okay, from there it directly goes to the local forwarder of the...
And then it goes to the local point-to-point forwarder, which establishes the local cross-connect point-to-point, and then the VXLAN tunnel is being set up between the nodes, and then finally the point-to-multipoint cross-connect is assembled on the originating node by the point-to-multipoint forwarder.
Okay.
Does it mean that the first forwarder will speak to another forwarder? I mean, at least they need to have the same media. You cannot mix the VXLAN forwarder with the VLAN forwarder.
Right, but it winds up being the same sort of it's the same sort of conversation as we had before, which is but
you only had one before, so it's no problem. Or
I'm sorry, what?
I mean, the mechanisms need to be negotiated. Right.
Yeah, the mechanisms need to be negotiated. Now, please note, in a point-to-multipoint case, it's conceivable that different V-wires from your point to your multipoints, different V-wires may get negotiated differently. So, for example, if on the local originating point-to-multipoint forwarder, I supported VXLAN and I also supported, just for sake of argument, SRv6, right? And I've got 3 NSEs that I want to do multi-point connections to. It's possible that the first one says, okay, VXLAN, we're good. And the second one says, okay, I don't know what this VXLAN thing is, but I do know how to do SRv6. So the V-wires may differ to the different multi-points. That's negotiated still on a point-to-point basis.
And you get slip on the last one. Serialized. I mean, couldn't you be required that you had the same characteristics on them?
That's up to the point-to-multipoint forwarder. Right. So, for example, if I'm, if I'm the point-to-multipoint forwarder, I can decide which mechanism preferences I'm willing to put into the list. So, if I want them all to have the same, maybe I just say, okay, the only thing that's good for me is VXLAN.
Yeah.
So.
Yeah. Okay. Any more questions? If not, then I hand over to the next person on the agenda.
Okay, cool. I would actually suggest, I know.
Thank you.
I know, Denise, you were wanting to do to demo a couple of things. You wanted to demo the admissions webhooking sample and DNS integration.
Maybe Ed, before we jump to the next topic, one final question from my side. This change to move the network service endpoint selection from NSM Manager to Forwarder, that is basically the first thing that needs to be done before we can start. No, probably more needs to be done. But how do you think we should attack this work?
So my off
now
the cuff
to make this happen, if the proposal is technically acceptable.
My off the cuff thought, and this is just off the cuff in terms of order of operations, would be that there are two pieces of work in terms of changes in network service mesh. The first piece of work would be moving selection from the network service manager to the forwarder. And it has sort of one really nice benefit in that we're not looping through the network service manager twice anymore, which has been a source of some complexity. And then the second one would be you would need to augment the network service API to include the metadata with labels on matches and add support for forwarder selection in the network service manager based upon that. And those, I think, are sort of the two chunks of work there that's sort of come immediately to mind.
Right, and the let's say the complexity of those changes they are such that this should be done by people that are intimately familiar with the inner workings.
So here's the thing. I would say that refactoring to move selection to the forwarder probably should be done. It strikes me as being a more delicate operation. Once that's done, I think actually adding the ability to select point to multi-point forwarders should be straightforward enough that it would actually be a really good thing for folks to garner experience in the community with. Because from that point, just sort of architecturally, the way things are set up, you've got some nice steps there where you have to change an API, you'd have to produce a chain element to do the forwarder selection, that kind of thing. Does that make sense? So the shifting of selection from the network service manager to the forwarder, that's probably somewhat delicate and requires some sort of thought and experience because there are a lot of things to unravel. But the actual implementation of capabilities-based selection on labels, that's actually a really good task for people to get their feet wet with, in my opinion.
Okay.
Make sense?
Yeah, makes sense. Yeah. So then the next question would be when do you think there is a time to for you guys to take the first step to do this refactoring?
So my suggestion would be, for a lot of folks in this discussion, this is sort of conceptually new. We were all here in the community when we talked about this as a sort of a use case we wanted to fill. In terms of the potential for this, I don't think it's had a chance for most folks to sink in. In particular, we have a lot of folks on the call who are super good at noticing implications of things and also good at tonally noticing them, not so much as objections, but as here's a problem we need to make sure we can solve. So my guess is there's going to be a little bit of sinking into people's heads. And there's also a little bit of figuring out sort of like what this gets done order-wise vis-a-vis other things in the backlog. So I would suggest the following: raise the question again next week, and there's probably a better set of answers when you raise it next week. Not necessarily a complete set yet, but a better set.
Okay, fine, fair enough. Absolutely.
Yeah. And for all the folks who are more familiar with some of these things, like I very much want to hear feedback from folks who are particularly familiar with like the network service manager code and that stuff. on sort of like problems you think we may need to solve in the course of this and those sorts of things. Cool. Anything else before we jump into demos?
Oh, yes, I have one question. Do you can you share the presentation, or probably you can create an document spec for this? It can be.
I will share the
useful
link to
for
the
us.
presentation. It's already in the folder that Ed
okay.
has set up. So just put the link into the minutes.
Yeah, so if you could just put the link the agenda item, that way folks can get to it. Because the deck itself is an excellent jumping off point to a lot of this stuff as well.
Done. Okay, then let me stop sharing.
Okay, excellent. Denise, do you want to share for demos?
Yep, sure. Let me a second. Oh, do you see my screen?
I do.
Okay, fine. Today I want to show a quick demo of features that have landed into NSM since last weeks. The first feature is related to admission webhook stuff. In short, it's about dynamically adding clients, NSM clients, into some external deployment to get connectivity for with some endpoint. So in this example, we'll deploy Alpine pods that have NSM annotation, and when we apply this, we expect that NSM admission webhook will parse this annotation and will append NSM client into Alpine pod. And when Alpine will start it, we went to see that Alpine got connectivity with endpoint that provide us this service. So let's a bit look at endpoint that will apply. So basically, it is patch for NSE deployment. It is related to customization Kubernetes feature. So in short, this is this part of YAML file that will be merged with another config. Give me show it. It will be merged with let's see, it will be merged with NSE kernel. To understand how to work customization feature, you could look at customization examples. In short, it starts with a customization file that have some definitions. So for this case, we'll base our customization file on NSE kernel customization. So let's look at this. So in short, it's another customization file that has a resource NSE YAML. So let's go to NSE YAML, and it is just a deployment that can be just applied from CLA. Let's return to NSE patch. So this thing means that we'll append containers Postgres. It is just a default Postgres image. It will append a container into this NSE deployment. So currently we have one container. When we apply this config, we'll expect that containers count is 2. Yeah, the first is NSE kernel and the second Postgres. So I guess we can just start with this example. I hope it will start fine. Okay, so also one thing related to our examples. If you see in our MD example requires section, you need to just go into all links that related to another examples, because you need to complete this example before start this. So here we also have requires section. Let's go to requires, and here again. So to start this example, we need to apply Spire stuff. So currently I have not some special namespaces, and I hope I have not some additional resources. Looks like it's fresh. So okay, let's go to Spire folder, and to apply Spire, let me check that I have deleted my previous admission webhook. So to start it correctly, I need to delete my dating admission webhook configuration. Okay, fine. Now my cluster is fresh, and we can start. So let's apply Spire stuff. It's applied simply. You need to just run kubectl apply -k. After this, you need to verify that all stuff is ready. We can just check it. So as you can see, Spire application started, and we can do next step. The next step is register Spire agents in Spire server. So to do it, you need to just copy paste this Linus. So Spire is ready. Now we can return back to a basic example. Go into basic example, and let's try to set up a network service mesh setup. Okay, we have created network NSM system namespace. Actually, you could use any namespace. It is not required. So we just using NSM system just for testing. So after this, we need to register this namespace in Spire. Let's do it. And we need also register Kubernetes, registry Kubernetes network service mesh backend in Spire. Let's do it. And after this, we are ready to apply a basic NSM setup. So let's a bit look at basic NSM setup. For this, we could just look at customization YAML file. And here we can look that basic setup is includes NSM manager, forwarder VPP, registry Kubernetes, and admission webhook. So let's verify that all applications have started. And looks like all applications started. So, okay, let's just back to previous example. Feature examples just requires basic setup. We have completed basic setup, so we can go back again. And we have returned it to admission webhook example. Now we're ready to run this. Okay, so the first step, we need to create testing namespace. Oh, sorry, I need to go into the folder features webhook. The first step, we need to create namespace. It is just a random namespace with a random name. Let's look what namespace has created, and it is this namespace. Okay, now we need to register this namespace in Spire. It's done. And now we need to select nodes, get nodes that can work. So some clusters have control plane nodes that are not run applications. So this command will just find all available nodes to set up. Okay, it's done. And now we will create resources for customization. The first thing is just Alpine pod that will be deployed at first node. And the second resource is patch for kernel endpoint. And now we can create a customization file. Okay, let's look at our current files in this folder. And now we have Alpine YAML that represents just YAML. It is just Alpine pod. The second thing is customization file. It describes what will be deployed when we apply, when we will apply with flag -k. Let's look at it. And here we see that we'll apply things in namespace that we have created at first step, and it will use NC kernel YAML files, and it includes Alpine pod and merge patch for kernel NSE. So now we can apply it and look what happened. Okay, NSE kernel has started. Okay, let's look at status of our pods that we deployed. Oh, and we got running 2 applications, and we got 2 restarts. It is not expected. I'll investigate this problem after this presentation, but looks like it is now stable. So I hope it is started correctly. We can verify it. So let's check it. So actually, in this example, we'll try to connect to the Postgres service from the Alpine that from the box have not network access to the Postgres service. So let's just exec from Alpine just exec sh session. Oh, fine. I have connected to Alpine container. Oh, also the major thing that I missed that as you can see, our Alpine deployment have 3 pods. Let's create another terminal to describe it. Okay, fine. I have described it, and in example, we just deployed Alpine pods that have not any additional containers, but when we applied it, admission webhook added a few containers. Let's look at them. The first container is Comede NSC init. This container has created, I hope it created connection to endpoint. The second container that I added is Comede NSC. The main difference between Comede NSC and Comede NSC init that Comede NSC init doing stuff for initialization connection on initialization stage of deployment. It is super required for some applications because we want to have a connection when our application started. So all init containers in Kubernetes running before other applications. So it guarantees that when our application started, we have connection at this moment. The second difference that Comede NSC is just manage connection. that has created by KMD NSC init. So it sends updates on connections and receives updates, and it refreshes tokens and so on. And the final container is core DNS sidecar. It is part of the second example related to DNS. In short, this container provides possible for clients to get access to DNS servers from the user side and from the Kubernetes side. So in short, again, it just doing all DNS stuff for the deployment. So, okay, now we can check that NSM has created for us required interface. For this, we can check if config, and as you can see, we have injected interface NSM1. So why we have NSM1 interface? Because we described it in this annotation. So how this annotation actually looks for NSM? The first stuff, shim is kernel. It means that our client went to connect to NSM with a kernel mechanism. And the second thing is name of service that we went to connect. It is my Postgres service. And as you can see, this is a name that we provided to our NSE kernel. And the final part is just a name of interface that should be created. And as you can see, it is created. So now we need to verify that we have connection from the Alpine. So for this, we need to connect to our Postgres database. So for this, we can just run these commands. We need to, it is just fresh Alpine. It have not some stuff. So we just currently installing Postgres into Alpine. So so when it installed, we can try to connect to our database. So let's a bit look at our database. From start, it configured that on start our NSE, it will create a database test for user admin with password admin. Okay, it is needed to get this string. So with this string, we'll try to connect to our database from a client tool that we installing right now. So let's try to do it. And as you can see, we have connected to our endpoint. We connected to a database test from Alpine without additional things with network stub. So NSM has provided connection.
That's fantastic. I do appreciate it. We're going to have to, I think, delay the DNS demo until next week because we're currently about 10 minutes over. And I do appreciate everyone sticking around for this. This is actually very cool. So thank you. Much appreciated, Denise. Cool.
Okay.
And anything else before we conclude? All right, excellent. Talk to you all next week.